Hello, everyone. Thanks for coming to our session so late in the conference. We hope that you'll find this topic both interesting, thought-provoking, and hopefully you can take some of the things that we present today back home and put them to work. My name, again, is Dave Gruber. I work for an industry analyst firm called the Enterprise Strategy Group. This is my colleague, Tyler Shields. He is also an industry analyst. We each have different coverage areas in the industry. I cover all things security operations, so I have a very broad focus for all the tech, processes, and interrelationships with security operations, and I'll let Tyler tell you what he does.
Absolutely, and I cover all things threat and exposure management and risk reduction. So between the two of us, we cover this topic in depth and detail with all the vendors, with all the practitioners, and hopefully with all of you giving us feedback on where you think this is going.
Yeah, great. So without further ado, Tyler.
Yeah, so I want to ask first real quick, how many practitioners in the room? How many cybersecurity practitioners in the room? It should hopefully be most of you because this is supposed to be for the practitioner.
It's okay if you're not. It's okay, don't be shy.
If you're not, the door's back there. No, I'm just kidding. Is this you at night? You know, your board wants to see run it all the way out. The board wants to see the latest metrics, that threats and exposures are piling up, you're afraid of the next hack. You know, this feels like something you might see in a clickbait news article, but when I talk to practitioners, a more subtle version of this is pretty consistent. Everybody's worried about the next hack. Everybody's worried about how do I protect the systems. And some people are even burned out saying, why do I even take this job in the first place? Why can't this be you, right? Don't we all want to be the Minority Report guy? We all want to be Tom Cruise and just flicking fixes left and right, you know, fix that problem, and it just works, right? What you want is visibility, is knowledge, is understanding, is continuous validation that things are being fixed and a continuous decrease in risk. That's what we all want. And I've been in cybersecurity for almost 30 years, 25 plus years, and somehow yet we can't get to this point with no false positive, no false negatives, and no automation for remediation. Somehow after almost 3 decades, we still don't have this.
But wait, there's promise. So looking at risk management in general, risk management, by the way, is a big topic. If you're a cyber pro, then you feel personally responsible for some amount of risk in your function, but risk is a broad term. Some of you have professional risk managers in your companies. Others, you're in smaller organizations where you feel full ownership for cyber risk. 65% of risk management professionals feel like they're at least somewhat more difficult than it was recently. And this is not a new idea or a new trend. As Tyler mentions, unfortunately, with the continuous spend on tech and process improvements, things haven't been getting better for a while for so many people. And this has been actually the case in the security operations function as well.
And if we dive down even a little bit further, if we don't become proactive, we're going to drown. Okay, this is some data from, I believe it's from VulnCheck, a company called VulnCheck, that shows growth in vulnerabilities, known exploitabilities, and proof of concept exploits. The really scary thing is the bulk of this is actually pre-AI, meaning pre-automation for attackers to create these things. And we're already to the point where we're drowning in vulnerabilities by published date over the last, whatever that is, roughly 10 years, 9 years on those graphs. Exponential growth is occurring. There's exponential growth in code, there's exponential growth in flaws and exposures, and there's exponential growth in risk.
So let's talk for a minute about where this fits into the broader perspective of security strategies. So this is a rather simple diagram that I put together a few years ago to take a look at how modern security strategies affect what I call the threat funnel. And I chose to use a funnel because as we look at reducing risk, we do so through a series of layers. And of course, we all know what layered defense, the concept of layered defense is. This is different. Think about the traditional terms of a sales funnel or other sort of funnel kind of metaphors where things come in the top and then as you come out the bottom, you're able to reduce sort of or qualify things as they go. So I use the funnel metaphor to show that there's a massive amount of threats that are upon us. The first layer of defense is our ability to defend our attack surface and lower and strengthen our security posture across the attack surface. And there's lots of different approaches that we use there. Of course, we're looking for vulnerabilities in all the different variables and aspects of the infrastructure, all the different threat vectors, all the way through back up and through the supply chain and the human element as well. That's a proactive function, and it's the primary function that we're going to be talking about today, but it's very tightly intertwined and related to the active security controls in place that we have. And again, most of those align to individual threat vectors. Sometimes we're acquiring those through platform or consolidated vendors. In other cases, we're running individual active preventative security controls. So that's sort of the proactive layer and much of what we're going to be focusing on today. The funnel itself is drawn like this because as we reduce the probability of those threats coming through the threat funnel, some number of those end up in the threat detection and response bucket, which is a reactive strategy. And all of us perform either some of this function, outsource some of this function, or have a formal security operations function in our company with a primary objective of handling detections and triaging, investigating, mitigating alerts in the process. So that's the threat detection and response layer. Of course, there's lots of technologies that are involved in that, and more modern solutions are starting to converge some of the proactive insights that are coming from the top of the threat funnel to make that part of threat detection and response. And of course, things that get through that layer end up being incidents, at which point we need to take action and mitigate whatever the damage was from those incidents, and hope that we don't end up in the very, very tail of the funnel, which is the recovery function here too. This maps very nicely, by the way, to the NIST framework. Here's the big takeaway from this threat funnel idea. The better job we do with the threat at the top of the threat funnel, the better we do defending our attack surface, reducing risk, reducing exposure, the less effort we have to do at the additional layers in the funnel. So our preventative controls have to do less work in the active security controls. Very importantly, the human-intensive functions that are involved in reactive security, we have to invest less. So less human effort that's expensive for us. And then so as we change the shape of the threat funnel, so this is our objective, the better job, what we're going to talk about here for the rest of the session, the better job we do at the top, the less effort we have to expend down, and the less risk and actual impact we end up in. Therefore, we stay out of the penalty box, which is at the bottom, which is the recovery piece.
So I want to take a second and let you digest what you just heard, right? There's a process that we can roll out. But what's the difference between proactive risk reduction and reactive risk reduction, right? It's this concept of left of boom and right of boom. Getting in front of the boom, getting in front of the moment when a breach occurs, takes technology that seeks out and mitigates those exposures before they pose a danger, right? If you remember the movie Minority Report, they have the precog concepts of these very, smart, I don't even know what they were, beings or whatever, that could predict when somebody was going to do something wrong. That's where we want to get to with our technologies, right? The reactive side, you can't ignore it, right? You still have to respond to problems that make it through. But we want to try to figure out how to get pre-boom.
Wrong way, sorry.
Go ahead and build it all the way out. Yeah. So how do we get pre-boom, right? There's two different things you have to understand from a threat and exposure management standpoint. You have to understand state, and you have to understand events. State comes by understanding programmatically what exists in your environment at any moment in time. And I'm not talking about a CMDB. I'm not talking about a list of IP addresses that tell you what hosts are in your environment. I'm talking about looking at every single asset class, piece of data, and understanding the properties of that data. If you can say, I have a cloud instance, it is configured in such and such way with these configuration components, and you can query a data set that gives you all that asset information, that's understanding state, thoroughly understanding state. And then what you from there want to understand is events, which is programmatically understanding changes in state, okay? We have an S3 bucket. It went from encrypted to unencrypted. That's an event, okay? So what we want to track in threat and exposure management is complete understanding, visibility, and knowledge of state, and complete understanding and visibility of events on state. And I know you guys are now going, holy smokes, that's a lot of stuff to comprehend, So AI becomes very, very important when we start talking about understanding and being able to get our arms around this massive data set. So what has changed to make the vision of an AI-driven proactive threat and exposure management system possible? There's 3 specific things. A few years back, the world became API-driven. Think of all the tools you have in your environment. Almost every single one of those security tools, technology tools, IT tools have API access to them, right? That's what drove companies like Wiz and others to become amazingly powerful, because they tapped into those APIs. So we have an API-driven world that allows programs to operate. We have big data and cheap storage. We have the ability to store massive quantities of data and make it accessible. And now, within the last 18 to 24 months, we've learned how to contextually analyze that data with artificial intelligence. Attackers are embracing AI. I hinted at this earlier. I mentioned it earlier. Those curves of risk are growing dramatically because attackers are automating the ability to discover risk, discover vulnerabilities, generate exploits, create weaponized versions of attacks, create malware, morph malware. All of that stuff is being done by attackers today. It makes it very difficult for us to keep up without AI ourselves. So we're entering an era of an AI arms race. So what is the chemistry of a true threat and exposure management platform that's risk-based? So I know that the text is a little bit small here, but it basically hinges on 3 things, okay? You have to have a thorough and complete understanding of your cyber asset data, okay? It gets back to understanding what you have in your environment in minute detail. You have to have a thorough understanding of the threats that are attacking those assets, and then you have to have the ability to execute security analysis, okay? So it's basically this mix of capabilities that we now have the ability to do programmatically that is giving us the ability to move more towards self-healing systems. So assets, vulnerabilities, exposures, and threats. Let's take 2 seconds. I'm going to run through these pretty quick. I want you to reconceptualize the attack surface to start with. Back when I was young, everything was in a perimeter, right? And I'm sure many of you have heard the, the crunchy outside and soft chewy center kind of perimeter model. That doesn't work anymore, okay? We have micro perimeters. So you need to start to think of your assets, each individually as its own little micro perimeter. What can I do to secure this particular asset? And it doesn't necessarily mean all I care about is an external view into my assets, right? Hackers and attackers have an external view into your assets. They're only going to see a subset of your asset base, right? But if you ignore the inside, we run into that same problem we ran into many, many years ago about the crunchy shell and the soft chewy inside, right? So we have to make sure that we've shrunk the perimeter down, right? And we look at both the inside and the outside asset base. You have to collect all of that data. So assets, vulnerabilities, exposures, and threats, they're what you have, what vulnerabilities each asset has, what exposures exist, and what threats exist. Now, I'm sure you're going, what the heck? Like, those terms really overlap a lot. So let's run through that diagram on the right by zooming in on each section. What is an asset? I already kind of went through this already, right? Define assets that matter to you. In an ideal world, you're going to track every asset you have. An identity is an asset. An IP address is an asset. An endpoint is an asset. A certificate is an asset. A cloud workload is an asset. A container is an asset. Like, I go on and on. The asset classes are endless. So define the assets that matter to your risk measurement, to the way that you run your business, and collect all of that asset data, including all properties and current config state, and track it continuously and programmatically, okay? This is possible. Many of your threat and exposure management platforms that are in market today have a very broad view of asset classes, and they're only growing. I literally met with all of those vendors this week, and every single one is telling me we're extending the asset classes that we track in our database. So automate that and look for software-defined groupings of technology assets. Now let's define vulnerabilities. I want you to be clear on what a vulnerability is versus an exposure, because they're not the same thing. And don't let people tell you they're the same thing. A vulnerability is a first-party or a third-party problem, often the result of bad coding, okay? So it's often inherited risk. You bought a company or bought some software that comes with vulnerabilities in the code, often a supply chain problem, and very difficult to discover, right? These things are often what result in 0 days. It's the CVE chart, right? Each of those vulnerabilities is generally tied to some code flaw somewhere. But an exposure is a superset of a vulnerability, okay? Exposures don't have to be, I created a buffer overflow bug in a piece of code. An exposure could literally be, oops, I left this identity with admin privileges. Those are exposures. So oftentimes people center on CVEs and vulnerability reduction. What we really want to reduce is the superset of exposures. So how do we actually do that, right? We include the misconfigurations and other mistakes that can happen resulting in risk. Exposures are measured in potential impact. And then the last category I want you to understand is threats, external threats, internal threats. These are essentially attacks or potential attacks against an exposure, right? That's what we care about, is what are the things that can happen if an exposure is there and we have threat actors that act on said exposure, what happens? So that's your threat intelligence and attack surface management technologies. They provide that outside-in view. It's active or potential, and oftentimes you have to look at not just the state, but the events that are occurring in your environment to understand threats.
I got a question for you.
Yeah, hit me.
There's a whole lot of data that we're talking about here. We just talked about 3 massive data sets.
Yep.
We all know that the vulnerability data set is massive. The exposure data set, more of a derived set of data, but one that's also potentially sizable. And of course, the threat landscape, massive in itself. The vendors that you're working with, are they managing, tracking, analyzing all of the data that you just laid out here?
Partially. So I don't think there's any vendors yet that have all of this in play. But this is the vision that the majority of threat and exposure management vendors that I'm speaking to this week are driving towards. And I think they have a great start. Many of them understand a broad asset base and are collecting large swaths of data in from an asset perspective. Many of them, almost all of them, understand vulnerabilities, because that's the history of the threat and exposure management market. And some of them merge threat intelligence data into their products. This is how you want to look at your vendors. This kind of understanding is, what do you provide me? And we have a framework that we'll build up a little bit later that talks about how that provides additional value.
Yeah, great. And so now let's sort of introduce, so when you put all this together, so you begin to paint a different picture, right?
Yeah, so when you put all this ingredients into the soup, okay, if you think of each of these things as ingredients, when you collect asset data, exposure and vulnerability data, and threat data, and you pour it all into the soup, it makes something called context. And when you think of how do I fix a vulnerability as a security operations person, you don't necessarily go right to, I got to fix the code. You think, what's the context around this vulnerability? What infrastructure is it on? Who owns it? Who's the administrator? All of these asset context helps you make a decision on the right way to remediate the problem. It's not just vuln patch. And often this week, I've spoken to some legacy vendors who tried to talk about patching things. I'm like, stop saying you're patching stuff, because you don't just want to patch a problem. You want to remediate the issue at the fundamental layer where it makes the most sense. And that's achieved through context, which is pulling all of this information into context that allows you to do better prioritization, better attack path analysis, threat risk elimination, et cetera.
Yeah, right. And so it's focus too, right? So
Yep.
it results in focus. So now we're going to introduce a management platform capable of doing all the things we need to do to process this and work with it.
So I know you all want to hear about self-healing systems and AI, okay? I love it. That's a killer hat, by the way. I know you all want to hear that, okay? And I will get to that. But you have to understand the foundation that the AI has to be built upon to be successful, right? And it's that data knowledge I just built. So if we build out this slide here a little bit, go ahead and do the whole bottom layer. That's fine. If you think of that bottom layer, that's your soup. That's your bundle of soup that I've been talking about, okay? You've got vulnerability and exposure data, you have asset data and threat data, and you've got it in some kind of big fabric that doesn't just put the data in there in a raw way. it interconnects and understands the interactions between all of that to create a context to be smart. Now, data in a big storage is hard to consume, right? So we have some kind of analysis engine that overlays the top of it. AI, ML, it could be just basic syntactical, right? It could be behavioral analytics, I forgot the third one. It could be any of those methodologies. And these are historical methodologies that we've been using for a few years, maybe even 5 to 7 years in the vulnerability management and threat reduction markets, right? But if we build out the rest of this, what results here is threat and exposure management platform that's looking at a holistic cybersecurity context, okay? We're not just focused on reducing vulnerabilities. We're looking at vulns, exposures, threats, and understanding all of it to make the ultimate prioritization and ultimate recommendations on remediation that we can. So if you look at the top right there, you see the actual outcomes that occur, okay? What people want out of this is visibility on my assets. They want to know what we have. They want really good prioritization. They want validation that things are getting fixed, and they want automated remediation. This is what everybody would like to have, right? I have 50,000 vulnerabilities. I can fix 45,000 of them automatically. That's what the dream state is. So go ahead and build out the whole thing. This is the AI version of it, okay? This is where the market is going. Not every vendor has this, but pretty much every vendor is talking about building this, okay? So if we attach AI to each of these layers of the framework, okay? In the bottom right here, we have a distributed data ingestion system. We use agentic AI to discover, hey, you just installed a brand new security tool. I'm going to connect to the APIs on that, probably over an MCP connection, agentically ingest the important data, or even in the moment of need, pull the data I need into my decision, and get that into that foundational fabric and normalize it so that it's usable. AI is used for the normalization process. AI is used for making that contextual soup as opposed to raw data chunks. And then you have a true AI analysis engine that hits that middle layer and can look at it all holistically, can look at it all in context and make smart decisions for you. And finally, on top, that ends up building a true threat and exposure management platform. And the coolest thing is on the right, when we really apply all of the new agentic ideas to what your outcomes are, that's when the value of a true threat and exposure management platform that's AI derived becomes powerful. So when a recommendation for fix comes out, today we might give you a list of things that you can go do, right? Here, do these steps. And it's really detailed, right? Log in here and click this and change this setting and you reduce your exposure in AWS. But what if that's actually instead, AI codes that into a CloudFormation or a Terraform file, pushes it into your GitHub system, and then your developer can just look at it and go, oh yeah, that fixes the problem, commit. Like he doesn't have to write a line of code. We're getting much closer to a self-healing system when that occurs. So you can feed that data through automations to make fixes occur. You can also have the agents directly connect to the APIs of the systems and flip the bits to make things better. This is how CTEM, Continuous Threat and Exposure Management, becomes an actual self-healing system.
Now you'll note that you all have walked the show floor at least some level, and you've all seen virtually every vendor on the show floor talking about what they're doing to invest in AI capabilities within their individual offerings and components. It's worth drawing a parallel here that says there's a tremendous amount of little red dots up here on the screen. There's two things to note here. One is it's not one engine, it's not one AI model.
It's not one master AI.
Right. So note that AI is going to get inserted into many stages within the process, so that's one dimension. The other is it's a journey. What you see here isn't going to happen overnight.
Absolutely not.
All right, this is a projected end state of where we see things a year from now. Honestly, I hope we're actually very far along, and I suspect that we will be. But you're going to see these improvements happen incrementally, and it's not an on-off switch either. It's not like, well, we're going to apply this function here and it's done. This is going to be a journey, and it's going to take a year, 2 years, 3 years.
Year to year and a half.
Yeah, like it's not that far away though. So it's coming up.
So how many of you, if I were to say to you, I want the agentic AI to pump out Terraform code or source code fixes and have it automatically get fixed in production, how many of you would sign up for that today? How many of you are scared of it? Yeah. The bulk of the people that I talk to on the practitioner side say, I would not sign up for that today. There's absolutely no way I'm going to let an agentic AI fix my infrastructure automatically. They're just too scared it's going to break things. We've been trained to be risk reduction people. We want to reduce risk. We're not going to let an agent run willy-nilly and crazy on our network. So how do we actually do that, right? Well, first of all, we have to map it to a process, right? So we understand asset discovery, we understand vulnerability exposure analysis, we understand prioritization, and then we hit the automated remediation process, right? And that feeds back into the discovery. But, and go ahead and hit the next slide, we have to, for the near term, keep the human in the loop. We can't just let the agents, the Terminators run wild and go fix things, because who knows what they're really going to do. So what we're going to do in the near term is keep the human in the loop. We're going to take data plus context. We're going to make a recommendation. And just like ChatGPT, we're going to have a thumbs up, thumbs down on the recommendation, right? So when the recommendation hits your level 1 or level 2 SOC analyst to go do process whatever, they say yes or no. And here's the fun part. We give them a percentage accuracy. How many times have you said yes to this particular recommendation over the last 6 months? 98.9% of the time, I just let it go. It's perfect. Well, guess what? Right next to that percentage accuracy number is a little button that you check the box that says, go ahead and automate this remediation. I finally trust it. So what has to happen for full self-healing systems to occur is a period of trust building. And that comes with a human plus AI contextual feedback loop.
Hey, I'm going to go off script just a little bit here because I've talked to a ton of companies this week, and there was another subject that came up, Tyler, that I wanted to just ask you a question about real time here on the stage. And that's the notion of, as we think about patching systems, one of the reasons why we're not all in on an automated fix is that it wasn't tested, it wasn't proven. So when you talk about trust, this is like, how do we build that trust? Well, as IT pros, what do? We roll out a few new systems, we apply a patch in a limited fashion, we test it first, we make sure we don't have an impact, and then we scale out whatever the deployment of the patch of or whatever that was. Some things that have come up over the course of this week was the notion of a digital twin. The ability for when you get to that question that you just talked about that says, do you want to let this go? Do you not want to let this go? Maybe the 95% confidence level, you let that go. The other stuff, maybe that flips over into a digital twin environment or a subset of the environment, so you have a proof point there before you move that forward. I'm just curious about your thoughts on that and how that affects the process.
I've heard some really cool, innovative young startups talking about that exact process. Where I think that falls actually isn't in the automated remediation component. I think where that should live is within the AI prioritization engine. So within the prioritization process, every change, ideally, assuming infinite resources and infinite money to do this, right? That's an assumption. We don't always have that luxury, but
bad assumption, but yeah. Okay.
We're going to make that assumption in this moment. I believe that lives in the prioritization stage, such that when a change comes out and you see a list of fixes that need to occur, exact steps, we hit that against the digital twin, make sure it doesn't crash, make sure it doesn't bomb, and then we feed it into the automated remediation section for the thumbs up, thumbs down, because now we've got another level of
more confidence
right? Of the prioritization. The really cool thing about that is if you feed that in, it may not recommend a code fix. It may recommend some kind of infrastructure fix to mitigate it because the code fix is too dangerous. That's where the AI prioritization engine gets rich.
Some virtual patch or some other alternative mitigation strategy.
Even before what you showed us, there's an earlier step.
It's within the framework as it moves up. That engine, the AI engine, does a prioritization process before it makes recommendations for fix. That's right, of course.
Yeah, so some really interesting, this is almost layering on further methods of mitigating risk further into the process to build the confidence.
Absolutely. So I want to take a pause there before we get to the future outlook and recommendations and where I recommend you guys go, and open up the floor for discussion and questions. I don't know how much time we have because I didn't look at the clock when we started, but let's open up Q&A early before we wrap on futures. Does anybody have questions? We have 6 minutes left. 15. We got time for tons of questions. Anybody have questions? Yeah, go ahead.
There we go.
So you were talking about how self-healing systems are going to do with current code as it's written, and I might have missed it, but what plans do you have to go through legacy code as that comes into the ecosystem? Do you have any process to look at legacy code and kind of heal that?
Yeah, I love that question. I think that's an excellent question. Look at it contextually. If you have access to the code, we're going to run our similar normal analysis tools that we've always run and feed those vulnerabilities into the threat and exposure management engine, which will make prioritization recommendations, et cetera. Oftentimes on legacy code, you can't directly fix it because it comes in a binary form, it's done via an M&A, and the person that developed it was long fired or whatever, who knows, right? The cool thing is we can actually, within that prioritization engine, you can tell the AI that this is unchangeable code. So it won't even try to recommend a code fix. The AI will be smart enough to then say, okay, given that it's unchangeable code, but it has to run, what are the other contextual recommendations we can do to secure that? So you can almost think of it as like a human's process. Now, don't get me wrong. I'm not saying this is here today. I don't want you to leave here and go, holy crap, where do I buy this thing? But this is what I'm talking to all the vendors about and pushing them forward toward. So I think it's a great question. That supply chain question is very important.
So I completely agree with the vision of where the industry should be going. But one thing I see that most organizations still struggle with is the basic context around assets themselves. And so this application is for these business processes, or this code is for this product, whatever it might be. And so the underlying context to a lot of this is that what these assets are for,
Yep.
and that powers what the AI is going to help prioritize. So how do you help solve that fundamental hygiene issue that every organization faces?
I have an answer for that, but it's nowhere near now. And the answer for that is having that agentic component, when it's doing its analysis, actually connect to business systems to be smarter and pull in that context. That's definitely not going to happen in the next few years. So think about it. If you also allowed that agentic self-healing system access to your design specs and your Google Drive that has all your business results and profit and loss by channel, it could be smart enough to say, this particular application is an internal travel application. We're Nike, and this particular application sells shoes on the internet. The AI is going to know this is way more important than this, right? That is so futures. I don't see it being something now. I think in the near term, we could see implementation of tagging, but in a more manual way, right? And eventually that tagging should become automated.
Yeah, but for a large enterprise, you're dealing with hundreds and hundreds of thousands of assets that are out there. That tends to be a very difficult problem that's required in order to make this effective.
Yeah, I think there'll have to be an enrichment process. Look, this isn't just going to be a turn on and it's going to work. You're definitely going to have to build it. And I think many vendors will claim it'll turn on and work, and it will for a certain subset of flaw classes, but not all of them.
Yeah, and then if you do get there, though, those crown jewels end up being a great target for attackers as well.
Absolutely. And I am very bullish on the future of this, but how it gets there and in what time frame is very much in question.
There's also the notion of behavioral profiling of assets, and there's been a lot of attempts at this type of things at the network layer. We also see this utilized often in the IoT space and industrial space, where at the network layer and the communications layer, we can see what the predictive expected behavior is for an asset, and therefore be able to classify it accordingly, and then assign a risk profile to it.
That'll come over
drive it.
Yeah. Any other questions? We can flip to the future. Apply what you've learned, right? Let's talk about what you guys can do today. Put your boots on the ground and get going, right? To your point, wherever the last question came from, inventory your crown jewels. You're going to manually tag some of that stuff. Know what's important to you, right? These particular workloads are important. These particular sections of code are important. Establish real-time visibility on exposures. I'm sure many of you have a vulnerability management technology or a threat and exposure management technology. That'll give you a number of these quick wins right out of the gate. What you want to do is push your vendor on the vision of, hey, what don't I know? What assets don't exist in this system? What assets does your decision-making technology, be it AI or ML or behavioral, not have access to? How do we get at that context? How do we continually enrich that data fabric and make it smarter, right? So what's your long-term strategy? Look for automation and automated remediation and the best prioritization that you can within your vendor products. I have had vendors this week say, hey, we detect more issues. I'm like, nobody cares, okay? If you detect 40,000 issues for me or 50,000 issues for me, I'm still freaking buried. What I care about is prioritization and fixing stuff fast. That's the key 2 points you should be pushing your vendors on. Align the risk metrics to the board level based on those outcomes. And success here really isn't about boiling the ocean. It's about building momentum over time. Don't necessarily, this is something I've been thinking of just the last few days, don't necessarily only hyperfixate on the highs and criticals. A lot of folks like, oh, we have to just fix those, don't worry about the lows and mediums. The lows and mediums are probably where your automation can be done first. And if you think about that for a second, if you really have 50,000 vulnerabilities and 45,000 of those are lows and mediums, how cool would it be to go to your board as a CISO and go, I just wiped out 45,000 of the 50,000 vulnerabilities. That would be pretty epic, right? Like a board's gonna love that. And you'll tell them up front, we didn't touch the highs and criticals, we were afraid it was gonna break stuff, but I still wiped out all the long tail. Automation's gonna be very powerful.
Yeah, and I think the other thing is we've been locked into some pretty rigid approaches and definitions of how to think about risk and vulnerabilities and the prioritization scheme that's behind them. AI, you should expect that as the AI models get developed by the vendors who are building these things, they're going to be more capable of looking at this risk perspective differently. And they're going to be able to create a different risk perspective that's not just simply based on criticals and not. It's going to actually be able to thread together what's the function of that asset? How does it fit together with other assets in the organization? What's the risk structure of what the risk posture and the risk policies are in the company? These things are all going to feed into this. We're going to think about risk differently in a less rigid fashion than when we do today. And that's almost disruptive to the way we talk about this. I almost will bet you 2 years from now, where we're standing here, we're going to have a very, very different perspective on how we're even thinking about risk.
It's going to be flipped. It's going to be flipped on its head.
Yeah, so it's going to be.
So the future's predictive. Risk management does not have to be reactive. Let's stop it from being reactive. Let's get proactive to fixing these exposures. I'm not saying ignore reactive. We have to know when we're breached, we have to go fix those things too, right? You can't just ignore that. But really, we should be pressing our AI advantage to becoming protective, preventative, and predictive. So the future of cybersecurity isn't about detection, it's about prevention. Let's get there instead of having to worry so much about, oops, we're already dead because we just detected an attack.
Yeah. All right, thanks everybody for attending, and we're on the tail end here.
I think we have a minute or two more for questions.
Yeah.
They haven't kicked us out yet, so happy to take them if you want.
Yeah, or people can come up and chat.
Or we can do it after.
individual. That's fine too.
Do we have 10 minutes? I don't know the time. Everybody's leaving anyways. Anyways, thank you
Okay.
guys. We'll hang around for questions.
Yeah.